Hi guys, welcome back to Tonic Audio after a very long break. It wasn't my intention to have such a long break, but things in the real world overtook my ability to make videos for a while. But we're back now, and hopefully we'll get a little bit more done in the coming weeks. So, what do we have here? This is a Raspberry Pi 4 based music server, which I cobbled together from a DAC power supply that I originally had, going back a few years ago now, and a new Raspberry Pi 4, which you can't see as it's underneath the hat board, and that hat board is a board that reclocks the digital signals coming out of the Raspberry Pi, and then transmits them to the DAC via the I2S bus. Okay, so let's talk about music servers for a minute. I have in my music room a Windows 10 based music server, which I think is very good. It certainly outperforms the good quality CD players I have in a number of ways. And I decided that I wanted to build something that had lower power consumption, given the cost of electricity these days. And also I really just wanted to explore how far the Raspberry Pi had come since I had one of the original models back about, I think, maybe 10 years ago. And when I trialled that as a music server, I wasn't particularly impressed, and that led me on to using my first Windows 10 based music server, which had a Micro ATX board. And again, I wasn't particularly happy with the sound quality there. It didn't stack up against the CD players I had in the house. Anyway, when you have a lot of time in your hands, but not a lot of money, you look for inexpensive ways of improving a hi-fi system. So, I spent the money and bought one of the new Raspberry Pi 4s, which was about 74 Australian dollars, in its 2GB memory capacity form, and this little hat that sits on top. The hat was, I think, about $30 Australian, and when I plugged it all together, I was really quite stunned at the sound quality coming from this device compared to my Windows 10 based music server. Not as smooth, not as detailed, but musically a lot more coherent. You know that sort of listening to appropriate music, it gets your feet tapping, you feel like singing along, and if you're of the type, you might even want to dance. So there we go. So this is just the initial build. The Raspberry Pi is a low-cost solution, but like all low-cost solutions, it has problems. Even high-cost solutions have problems, but perhaps even more so in a product of this price. The major problems are quality of the power supplies, and also the quality of the digital signal in terms of jitter that the Raspberry Pi produces. It actually has quite bad jitter performance. So this little blue board here on top of the Raspberry Pi reclocks that signal, so that when it's fed to the DAC, the jitter has been reduced. And I subscribe to the idea that low jitter tends to go towards a more musical performance, certainly a more pleasant sounding performance. Okay, so if we leave the Raspberry Pi to one side for a minute and we go into the DAC, unfortunately, this board is no longer available. It was one of the best cheap dual AK4495 DACs on the market, in as much as it was well laid out, individual power supplies for digital, analog, and one of the other aspects of the digital system as well. So it's 5 for, I think, the input side, 10 volts for the digital output side, and in this case 12 volts for the analog side. One of the reasons I liked the board was that while it came with all the surface mounts components, already pre-soldered. You got to choose the through-hole capacitors and op-amp devices that you wanted. And I spec'd it up quite reasonably here using either Elma Slimik, Panasonic FM, and in the case of the filter circuits, Amtrans. I can't remember the model range of the Amtrans capacitors. Always been a good sounding DAC, but in this scenario where it's directly connected between the source of the music and the DAC board itself, it has very good performance in my opinion. Okay, so the power supplies are power supplies I had when I originally built this DAC. These two power supplies, which supply the digital side, come from an American company called K&K Audio, and I've always had great success with their kits. The kits are quite expensive really. They retail for $45 US, but they do have the transformers on board, and that simplifies layout. This board here, I think is what's called a Kubota or Kubota power supply, designed as the name suggests by a Japanese chap, for use with the analog side of audio circuits. And again, it does seem to do a good job, although I have read that having an input voltage about 10 volts higher than the output voltage results in a better performance, but there's no room here to mount the pass transistors on either large heat sinks or to the body of the case. So I'm running it with a 15 volt input and I'm getting about 12 volts output, and everything stays nice and cool. Other things, the Raspberry Pi, the Pi 4, runs very hot. So what I've done to counter that is and I'll put some links in the text when I upload the video. What I've done to counter that is to have a large heatsink which forms both the bottom and top plate for the Raspberry Pi. Originally I had this without a fan, but it was still running quite hot, so I have implemented a small Noctua fan with its own external power supply. Internal controller, external power supply. That keeps the temperatures down. The other thing that is problematical, it appears, with the Raspberry Pi board is that given that it now has Wi-Fi on board, the aluminium case surrounding, which covers both the top and bottom board, seems to reduce the incoming signal strength to the extent that Wi-Fi is pretty ropey, particularly once the case is fully reassembled. And I have been using an Ethernet connection for control and for streaming of music. This seems to work well. Some people say Wi-Fi sounds better or has less impact on the sound quality, and I will have to test that. But to me, having all those radio signals bouncing about the board isn't going to be helpful for the music in the end. So that's basically it for today. A word about my intended upgrades. As I said earlier on in the video, the two main problems with the Raspberry Pi are noise from the power supplies, noise from the onboard DC to DC converters, and the fact that the I2S digital audio signal, when passed through, this is what they call GPIO, I can't remember what that stands for at the moment, general pin in and output, something along those lines, has quite a lot of jitter in the signal. So the upgrades are going to be an Allo, a company that supplies bits and pieces for Raspberry Pi devices, Allo Shanti power supply. That has two power outputs on it. One will power the Raspberry Pi, the other will power the hat that sits on top of the board. And talking of hats, the other item I purchased is from a guy who sells a lot of stuff through DIY Audio Forum, but is also available through Audiophonics in France. And that is a board, a very high quality board, that reclocks the digital signals and provides a degree of isolation between the Raspberry Pi and the reclocking board. Those should arrive in the next week or so. So I look forward to experimenting with those, seeing how much of an upgrade is possible. And then we'll move on from there and see if there are any others in areas in which we can improve. One thing that does come to mind is that I may actually build the Raspberry Pi based music server as a standalone, in which case it will be composed of the Pi board, the high quality reclocking board, the high quality power supply, and also output connector over HDMI, which will then send the signal over HDMI LVDS to a DAC equipped with an HDMI LVDS input connector. And that will allow it to be standalone and to be used with a variety of different DACs for testing. So there we are, that's it for today. I hope you enjoyed the video, and if you have any questions, please post in the comments section and I'll do my best to get back to you. As I say, if you enjoy these videos, please subscribe and turn on your notifications, just in case I do any more. Only joking. Thanks, bye.